Hello all. Our project is called Urban Mining and the Recycle Circular Economy. We are mainly targeting two goals here, that is transportation cost benefit analysis and the estimate of greenhouse gas emissions. I am myself Achal and my teammates are Gigi, Wanlu, Shiki, Zongze, and Kwanson. So as I mentioned, our objective is to compare the standard process with the uh, recycling process and do two calculations, that is of transportation cost and estimate the greenhouse gases. There are some reasons we are doing it. This is because recycling allows to recover valuable resources. If you look at New York State, 46% of waste is from concrete, and the circular economy helps in reusing, recycling, and repurposing of not only concrete, but it has potential for other materials as well. The state is also pushing regulations to move away from landfills. Lastly, circular economy creates opportunities for reducing waste, conserving resources, and improving sustainability. So for this project, as example case study, we have choose Jamaica Hospital as our location, and we compare it normal process with the recycling process. Normally, from New York, waste is landfilled into Hazleton, Pennsylvania, and on the other side, we are comparing it with a recycling plant that already exists in New York State. We are calculating transportation costs using number of variables and also the greenhouse gas emissions for the same.
This is the formula for calculating the transportation cost of standard process, which includes three components: total fuel cost, tipping and disposal cost, and total truck rent. First, we use CF denote total fuel cost by using total distance in the process divided by unit truck mileage. We got how many gallons of fuel are needed by a truck. PF stands for unit price of fuel, which is $3.4 per gallon. C divided by M multiplied by PF is the cost of fuel needed for a full truck trip. And for the N is number of truck, which equal to Q divided by Q1. Q is amount of construction and demolition waste material in town, and Q1 is maximum load capacity per truck. In this case, the truck's maximum load capacity is 22 tons. Second, the tipping and disposal cost is equal to C multiplied by Q, which means unit tipping or disposal cost multiplied by amount of CDW material. Finally, the truck rent is denoted by R. R is equal to N multiplied by T multiplied by R. The lowercase t is time required for a full truck trip, and lowercase r represents unit truck rent, which is $100 per hour. The sum of these three components is total cost of process. After divided by amount of CDW material, we got unit total cost of process. Next.
I will introduce transportation costs for the recycle process. In our case, there are two distances. The first one is from Jamaica Hospital to Washtag, and the second one is from Washtag to bench plant. The cost is calculated as the sum of the cost of transportation for the first distance and the second distance. For each distance, the cost is determined by multiplying the distance by the sum of the fuel cost, tipping fee, and truck rent. Just like the calculation of standard process, I want to explain more about the second part. Here is a mathematical representation for the total cost of the transportation. For the second part, we have some difference in the calculation of fuel cost and tipping fee. As we can see, there is a variable P. P means the percentage of sand, because only 60% of sand got from the soil will be transported in this process. And the cost is determined by multiplying by P. For the truck rent is similar to the first part. Next, please.
As this part is talking about greenhouse gas emission of standard process, as you can see, this equation is used to calculate the total greenhouse gas emissions, and it is equal to gas consumption times CO2 emissions. The first part of the equation is Q divided by Q1. It represents the number of trucks needed to transport all the CDW material. This ratio tells us how many trips truck will need to make to transport all the material. The middle part of the equation is D divided by M. It means the amount of fuel consumed by trucks during the transportation process, as it's proportional to the distance traveled and inversely proportional to the truck's mileage. And the last part is E. It represents for the CO2 emissions per mile produced by the truck. To sum it up, this equation represents the total greenhouse gas emissions generated during the transportation of construction and demolition waste material. Next, please.
So the next part is the greenhouse gas emission of recycled process. Here's the equation how we get the greenhouse gas emission under this situation. So the total greenhouse gas emission equals to the sum of the gas consumption from Jamaica Hospital to Wash Tech and gas consumption from Wash Tech to Rock Plant multiplied by the CO2 emission ratio. One variable need us to pay attention here is the P, which is the percent of sand got from soil that need to be transferred between Wash Tech and the Rock Plant. P equals to 60% in our case. The equation represents the total greenhouse gas emission generated during the transportation of recycled construction and demolition waste material. Next, please.
Since my teammates have already had a detailed description about our models, so we'd like to share more about how to use the calculator on our website. So here is our website. As the background and the introduction has been mentioned by my teammate, I'd like to show you how we use a calculator. For the standard process, let's use the number in our case. We put 290 miles for the total distance, and it's 450,000 tons for the amount of the material. Then we get the average transportation cost for almost $100, and the average emission is 5.36. Regarding a recycled process, we get the distance for 41.2 for the first one, and then 22.6 miles as a second journey. The total amount of material is 450,000 tons as well, and then the percentage is 0.6. Then we can get the transportation cost for more than $26, and the emission is about 0.79. Let's go back to our slides. So we also have the sensitivity analysis regarding the transportation cost and the emission. The study finds that in the standard process, increasing the truck allowance by 1 ton reduced transportation costs by $2.3, while a $1 increase in fuel cost raised costs by $33.3 per ton. In the recycled process, a 1 ton increase in truck mileage resulted in a reduction of $0.37 per ton in transportation costs, while a $1 increase in handling or tipping fee increased costs by $1.6 per ton. For the greenhouse gas emission, we found that increasing truck mileage by 1 mile was found to be an effective strategy to reduce greenhouse gas emissions in both the standard and recycled process, resulting in reduction of 1.07 kilogram and 0.18 kilogram respectively. The recycling process provides cost savings in transportation and reduces greenhouse gas emissions. Despite the tipping fees charged twice for 2 journeys, companies can rent trucks with a larger bearing weight and higher fuel efficiency to transport more material in few trips while consuming less fuel, reducing transportation costs and minimizing greenhouse gas emissions. Operational efficiency can be improved by minimizing the number of journeys required to transport materials by consolidating loads or optimizing routing to reduce overall tipping fees and lower transportation costs. Choosing trucks with higher utilization rates that are optimized for fuel efficiency and have high utilization rates can reduce emissions. And companies can explore options like shared transportation or route optimization to improve utilization rates and reduce greenhouse gas emissions. Thanks to our sponsors, Terry, Jennifer, and thanks to Todd, who provided us data. And that's it. That's all for our presentation, and thanks for listening.